Last week in our previous class, I requested for topics that you would like us to revise. So some topics were dropped. So we're starting with acid, base, and salts. Now we'll be looking at this under this objectives. We're going to define acids. I'm going to classify acid based on the source and the strength. We'll discuss the properties of acid. Thereafter, we'll look at some past questions and how to answer correctly. Now, acids generally are referred to as proton donors. When they dissolve in water, they produce protons, hydrogen ion as the only positive ions. There's so many examples of acids. Hydrochloric acid. Now this is IGCSE, so the names I'm going to use here should not be used for WAEC. Hydrochloric acid remains HCl. Nitric acid, that is HNO3, so that is basically for IGCSE. And sulfuric acid, H2SO4. Now, we all know also that all acids contains the element hydrogen in it. Now, we're going to classify acids based on the source and strength. Based on the source, we have two types of acid. The organic acid, which are gotten from plants and animals. Examples, I have ethanoic acid gotten from vinegar. I have lactic acid from sour milk. I have citric acid from lemon, lime, citrus generally. Then methanoic acid is present in ants and bee stings. The other class of acid based on source, the mineral or organic acid, they are man-made, they are synthesized. Examples, carbonic acid, hydrochloric acid, phosphoric acid, nitric acid, sulfuric acid, etc. Now, classification of acid based on the strength. We have strong acid, which we ionize completely when dissolved in water. Example of such, we have the nitric acid, sulfuric acid. The second type, we have the weak acid, which is going to ionize partially when dissolved in water. A typical example of that is the ethanoic acid. Now, properties of acid, the physical properties. The first one, an acid should turn a blue litmus paper to red. Second one, certain, but remember, you're not to taste anything in the lab until you're told to do so. Then the concentrated form of acids are usually corrosive. The chemical properties. The first one, an acid is going to react with elements higher than hydrogen in the reactivity series to liberate hydrogen. We looked at this when we're treating preparation of hydrogen previously. Secondly, an acid is going to react with both soluble and insoluble carbonate to liberate a salt, CO2, and water. Thirdly, an acid will react with base to form salt and water only. That is neutralization reaction. And lastly, what I have here, an acid will react with ammonia to form an ammonium salt. Now, let's look at some past questions and let's consider the answers. The first one, how will you distinguish between a strong acid and a weak acid? Now, if you're to answer this, please don't give theoretical things. You have to talk in practical terms. What do I mean by that? You're to give a typical example. For example, a metal higher than hydrogen in the reactivity series is magnesium. When an acid is added to magnesium, bubbles will occur. Now, for a strong acid, the bubble formation will be rapid, very fast. Meanwhile, for a weak acid, the rate of formation of the bubbles will be very, very slow. So the second question, which element do all acid contain? As I've said earlier, all acid contains the element hydrogen in it. And the last question I have with me here, I've given this as a class task already, so for those that did not attempt the task. Without using an indicator, how will you show that a substance is an acid? So I have various steps that can be used there. The first one, if you add a reactive metal to such substance, you're going to have production of bubbles, effervescence will occur, fizziness, and that's to buttress the point that hydrogen gas will be released. Now you have to go further to describe the test for hydrogen gas. The second answer that can be given, addition of a carbonate. By the time you add a carbonate to a substance which is an acid, we're going to have bubbles production, of course, effervescence will occur, and that's the production of CO2. You can test that gas also by passing over lime water, which is going to turn liquid. And the last one I have with me here, addition of a base, which is neutralization reaction, leading to formation of salt and water only. Now, having said this, join me in the Google Classroom for further discussion. Thank you.